In this video, I'm going to show you how to find the eigenvalues and the eigenvectors of a 2 by 2 matrix. For example, given the matrix A, which is 1, 2, 3, 4, or that is 1, 2, 4, 3. So finding the eigenvalues of this matrix, we have to use this formula, that is the determinant of A minus lambda I. We equate it with 0. So our A is the given matrix, while lambda is the eigenvalue and I is the identity matrix. And this identity matrix should have the same order as the given matrix. Now, A minus lambda I is just 1, 2, 4, 3 minus lambda I is 1, 0, 0, 1. This one will be 1 minus lambda times 1, but we can simplify this by writing 1, 4, 2, 3 minus lambda times 1 will be lambda, lambda times 0 will be 0, lambda times 0 is 0, lambda times 1 is lambda. Now, this one should give us 1 minus lambda, that is 1 minus lambda, 4 minus 0 is 4, 2 minus 0 is 2, 3 minus lambda is 3 minus lambda. Now, finding the eigenvalues, we will find the determinant of this resultant matrix, whereby we multiply the elements of the main diagonal and subtract with the elements of the secondary diagonal. Now, we will have 1 minus lambda multiply with 3 minus lambda minus 2 times 4, which is 8, is equals to 0. Now, 1 times 3 is 3. 1 times negative lambda is negative lambda. Negative lambda times 3 is negative 3 lambda. Negative lambda times negative lambda is positive lambda squared. Then we have minus 8 is equals to 0. Now, we have lambda squared. As we collect the like terms, we have lambda squared minus lambda minus 3 lambda will be minus 4 lambda. Then we have 3 minus 8 will be minus 5 is equals to 0. Now, we can solve this because this is a quadratic function, whereby we can solve using factorization method. We will have the sum to be negative 4, and the product is, the sum is this, the coefficient of lambda, and the product will be the coefficient of lambda squared multiplied with c, the constant. That is 1 times negative 5 is negative 5. Now, let us find two numbers. When we add them, we get negative 4, and when we multiply them, we get a negative 5. The two numbers can be negative 5 and 1. Now, let us substitute these two numbers in this function, that is lambda squared minus 5 lambda, then plus lambda minus 5 equals to 0. Now, factor out lambda. Lambda into lambda minus 5 plus 1 into lambda minus 5 is equal to 0. Now, lambda minus 5, we have lambda plus 1. Now, lambda minus 5 and lambda plus 1 should give us 0. Therefore, lambda minus 5, we can equate lambda minus 5 with 0 or lambda plus 1 with 0. Lambda minus 5 equals 0 or lambda plus 1 equals to 0. Therefore, our lambda can either be 5, or because if we take 5 to this side, we will have, because this is negative 5, so if we take to the other side, it will be positive 5. And in this one, if we take 1 to the other side, it will be negative 1. Now, these are the eigenvalues. So the eigenvalues are lambda 1, which is 5, and lambda 2, which is negative 1. These are the eigenvalues. Now, let us proceed to find the eigenvectors of the matrix. Now, the formula for finding the eigenvectors of the matrix is A phi, which is vector A times vector phi, is equals to lambda times vector phi. Now, this one is the eigenvector, and this one is the eigenvalue. This is the eigenvector. This one is the given matrix. For you to find the eigenvectors, you have to find the eigenvalues first, then you proceed to find the eigenvector. Now, finding the eigenvector, we have to take our A, that is 1, 4. Then we also have 2, 3. Then we will have our phi, that is vector V, as let us take our vector phi as x1 and x2. Then we will take our first lambda, which is 5. Our lambda as 5. Taking our lambda as 5. So we will have 5 times the eigenvector, that is x1, x2. Now, if we multiply this one, this matrix, with this vector, which is the eigenvector, then we also multiply this with the eigenvector, they should be equal. We equate them and proceed to find the eigenvector. Now, 1 times x1 will be 1x1, which is x1, plus 2 times x2, which is 2x2. Then we also have 4 times x1 will be 4x1, plus 3 times x2 will be 3x2. Should give us 5 times x1 will be 5x1, then 5 times x2 will be 5x2. Now we equate this one with this, and we also equate this one with this. So we will have x1 plus 2x2 is equals to 5x1. Now collect the like terms. If we take x1 to the other side, we will have 4x1 is equals to 2x2. Now x2 can be, if we divide here by 2 and divide here by 2, 2, 1, 2, 1. By 2, 1, by 2, 2. So x2 will be 2x1, 2x1. So if we have our first eigenvector as x1 and x2, then we have our x2 as 2x1. Then we just replace x2. So our vector 1 will be x1. Then instead of x2, we write 2x1. Now, in this, we can factor the common factor, which is x1. Then we have 1, 2. So this one is our eigenvector. Phi 1 is 1, 2. This is our first eigenvector. Now, proceeding to find the second eigenvector, Now, proceeding to find the second eigenvector, we have our P1 as 1, 2. That is our first eigenvector. Now, finding the second eigenvector, which is V2, that is V2. V2, we will have our lambda as lambda2 as -1. Now, to find this one, which we can also take it as x1, x2, we can also take it as x1, x2. Finding the second eigenvector, we will also have this formula, that is A times V is equals to lambda times V. So our A is 1, 2, 4, 3. Our V is x1, x2 is equals to lambda times our V, which is x1, x2. Now, we replace, instead of writing lambda, we will write -1. So we have 1, 4, 2, 3. x1, x2 is equals to -1. Then we have x1, x2. Now in this, we also do as what we did with the other one. That is 1 times x1 will be x1 plus 2 times x2 will be 2x2. Then we also have 4 times x1 will be 4x1 plus 3 times x2 will be 3x2. Then we equate it with -x1, because -1 times x1 will be -x1. -1 times x2 will be -x2. Now, if we take this one and equate with this one, that is x1 plus 2x2 should give us -x1. Now, if we bring this x1 to this side, it will be x1 plus x2. x1 will be x1 plus x1, which is -2x1, x2, not x1 but x2. Because if you take this one to the other side also, it will become negative. And bringing this one will be positive. So this is 2x1 is equals to -2x2. Now, this if I if I divide this -2x, -2 in this side and -2 in this side, we will have -x1 should give us positive x2. So in the eigenvector, the second eigenvector, we shall have our x1, then instead of x2, we replace with -x1, -x1. Now, in this, we have our V2 as x, we factor out x1. So we'll have x1, then we have 1, -1. So our V2 will now be our 1, -1, and that is our second eigenvector. Therefore, we have found the second eigenvector. The first eigenvector was 1, 2, and the second one is now 1, -1. That is how you can find the eigenvectors in a 2 by 2 matrix. So I think that is the end of our discussion today on how I wish that you could subscribe to my channel, because I will be uploading each and every time. I will be uploading content, covering much. I'll be covering much in mathematics. That is, you might find some concepts. You might find me addressing some concepts, and all in all, how I wish that you could subscribe so that you cannot miss any video of mathematics. Thank you.